Hi guys, Mr. Palmer back again with number 5 in our physics midterm review. This one is our elevator problem. Uh, let's start this one out by making a free body diagram. So whenever we're talking about forces, we want to make a free body diagram. In this case, we have an elevator we know that has a mass of 2,900 kilograms. Every object is going to have a weight. So we know that there's the force of gravity down. And it's asked us to determine the tension in a cable that's holding it up. Well, obviously if it's holding it up, the tension is going to be pointed up. So there are two forces involved in an elevator problem. And it's asking us to determine the tension of the cable under the following conditions. Well, we need to understand some relationship between tension and the weight. So in each one of these conditions, regardless of what the object is doing, we can look at the net force, right? Again, the sum of all the forces, which is simply the sum of the tension and the weight. That is the force of gravity. Now, some people, if we're looking at this, since tension is up and as gravity is down, we know that gravity is always going to be a negative because it's in the downward direction. So some people actually write this as Ft minus Fg is equal to the sum of the forces. And you just need to understand why that minus is there. That minus is there because gravity's pulling down and the tension is pulling up. It's directional. So both of these are correct if you understand that in the first case here, this is going to be a negative number. Okay? So let's talk about part A. It says the elevator starts upward from the ground with an acceleration of 1.1 meters per second squared. Well, the net force we can also write as mass times acceleration. We have a mass, we have an acceleration, we can put that in. The mass is going to be 2,900 kilograms, and the acceleration is up, so we're going to call that positive, and it's 1.1 meters per second squared. We're looking for the tension, Ft, and now we're going to put in the weight. So again, because gravity is downward, we're going to make this a minus, right? We're adding a negative vector. And the weight is going to be, well, how do we get that? Fg is equal to mg. So we can replace that with 2,900 times 9.8. So if you go and do the math on this one, this is on the right side, we're going to have a net force equal to 3,190. That's positive because it's in the upward direction, newtons. We're looking for the tension, Ft, and we're going to multiply our weight, which is 2,900 times 9.8. We get 28,420. So to solve, we're going to bring this 2,800 to the other side. We're going to add it to both sides, and that's going to leave us with 31,610 newtons equal to our tension. So that is part A. Now we can apply this part B. So the elevator comes to a stop at the top floor with an acceleration of 1.1 meters per second squared. So now instead of accelerating up, we're going to accelerate down. So this 1.1 is really the only thing that's going to change. Instead of writing positive 1.1, we're going to put negative 1.1 equals the tension plus the weight, and the weight is negative, so that's negative 28,420. And you'll see that this time when we go to add 28,420 to both sides, this is going to be positive over here. This is going to be a negative number on the other side. This is going to be negative 3,190, same value, equals tension minus 28,420, which gives us a tension of 25,230 newtons. So keeping in mind, if we're talking about this object, right, in the first case in A, the tension wound up being greater than the weight right? That's how we know it was accelerating in the upward direction. And now it's accelerating down, and we wind up with a tension that is less than the weight. If the tension is less than the weight, it's going to accelerate downward. For part C, that's really simple. For part C, if something is at constant velocity, that means the net force is equal, the net force is equal to 0. That means that tension is going to be equal and opposite the weight. Those forces will be equal and opposite since the net force is 0 because we have 0 acceleration. Which simply means we can write the tension is 28,420, and because gravity is pulling down negative, we're going to write this as a positive because it's in the upward direction. All right, that's it for elevator problems. Stay tuned for another.